Hello everyone, Stewart McGregor Merlin ERD Limited Technical Development Director speaking. How are you doing today? I'm sorry I can't be there with you in person at this SPE workshop on extended reach drilling, latest technologies and best practices. I'd love to come to Abu Dhabi and visit you all and say hello. The title of my presentation is Plugging Management System Gaps to Improve Drilling Outcomes. So as it says, we're going to be talking about the sort of processes and procedures that your typical drilling engineer will use throughout their career in order to try and identify the gaps that we often see in our operational results. So not every tool requires to come out to the rig in a basket, and I'll talk a little bit about some of the tools that we have in our arsenal as this presentation goes on. This presentation today, what's it all about? We're going to cover three items. First item being management systems, so what are they for? What do they look like? The second part of this will look in a little bit of detail about a meta-analysis that we undertook at the end of 2019 on 50 lost in hole events that we reviewed. What we did on that was we ranked them, we assigned contributing factors to each event, and then we ranked them in order of prevalence. And we'll use that order of prevalence in those individual events. We'll cross-reference them against whereabouts in the management system we think we should be able to risk assess against them. And then at the very end of the presentation, we'll talk about what can we do to fix it. So what are those things that we need to do in order to plug the gaps? Here we have an example of a management system structure. On the left-hand side is the one that we use internally at Merlin, but pretty much most of the large and small operators of the industry have something along these lines. They may not use exactly the same words for each of the individual phases, which are identified by the words inside the large orange circle, but pretty much we're doing the same things at each point in the process. So for our one here, we've got identify, plan, execute, measure, and review. So from our perspective, the identify phase is identifying a solution to a particular problem. That might be a well design issue, conceptual well design itself. So we're looking at all of the individual elements that will lead up to identifying that particular solution. So it might be a detailed offset well review, a feasibility study, a conceptual design document. But at the end of identify, we want to have some plan that we can test via a third-party review group that's going to allow us to move from that identify phase into the planning phase. So at the end of identify, we figured out what we need to do. In the planning, we're going to go off and we're going to do some detailed planning to get to the point where we're ready to start turning and burning at the rig. So I'm developing my detailed drilling program, my regulatory documents, my contracting strategy, my AFE, to the point where my gate at that stage is, do I have all that detailed planning work done in enough detail, funnily enough, in order to be able to make a good fist of execution. Execution is rig on location, drilling and completing a well. Whilst we're doing that, we're measuring what we're doing, and we're reviewing it, and we're feeding it back in to the next well, or the next time we're going to run casing or run completion. So it's a fairly straightforward loop. We've got these gate points that we need to hit with external review that are going to allow us, or allow our organization to check that we've done our work properly in order to move to the next phase. So just to give you a few of the little gotchas here and some of the things that we often see. At the identify phase, it's quite common for us to identify that an offset well review, for example, hasn't been done in enough depth in order to assure that the risks have been captured at that stage. In the planning, the transition from planning into execution, there's often those interface issues, particularly if you've got different teams doing different things, that we often see trouble there where it doesn't move as smoothly from plan to execution as often the case. And then in the measure and review, everything on the rig's measured these days, but often taking those measurements, reviewing them correctly and integrating that into the next plan is where it all falls over. Talking about things falling over, here's a quick presentation on the meta study that we did at the end of 2019. So this was done over a 10-year period from around about 2009 to 2019, consisting of 50 BHAs lost in hole. So as you can imagine, there's quite a lot of money associated with 50 tool strings lost in hole. We estimate around about $250 million just related to the lost in hole charges associated with the LWD tools, the directional drilling tools, the collars, and so on. Now, the bigger picture with that is that it's not only those charges that we've got to account for. By the time we roll in the spread rates, getting back to where you started before you lost the tools, you're looking at over $1 billion in non-productive time. And yes, it's very easy for us in the cool calm of our office in Perth, presented with a whole load of daily drilling reports, to say that all of it was avoidable. But when you look at the risk assessment work that was done, the offset wells, we see in all cases that these events were avoidable, where the correct things focused on at the right time, essentially. So we tracked a whole load of contributing factors, and what we've done here on the right hand side is ranked them in order of prevalence. So we've got 8 here, 1 second equal for operating instability, wellbore instability and operating limits, and then 4, 5, 6, 7. So because we're limited in time today, we'll talk about operational practices and then wellbore instability and operating limits being second equal. And then very quickly, we'll just go through the diff sticking, hole cleaning, equipment failure, and then the whole geometry and pattern slide at the end as one slide. But we'll look at the first 3 in a little bit more detail. As you saw from the previous slide, the highest ranked problem event taken and found as a contributing factor, a causal factor, in 30% of the lost in hole events was related to operational practices. So what does that mean? So operational practices, things like back reaming, tripping, making a connection. So no surprise that these are high risk events. The risk profile of extended reach and angle wells are very well understood, and I'm sure we'll all understand intuitively that it's typically one of these 3 events that's going to cause you problems on these sorts of wells, with back reaming being the #1 causal factor of lost BHAs, and so on. So why is this the case? Well, if you have any other dysfunction in the hole, for example, if you've got a dirty hole, then that's going to mean that you're likely to have problems from an operational perspective whilst you're tripping or back reaming or making a connection. So no surprises with any of this stuff. But the question here for us is, whereabouts are these risks identified, or where should they be identified in the planning cycle? So if we identify them during the execution phase, then you can argue very successfully that you're already behind the curve. The last thing we need to be doing is making up a set of operational procedures to start back reaming while we're actually trying to get off of the bottom of our 12¼ inch hole, for example. I'd also contend that if we're thinking about this in the detailed planning, or this is the first time we think about it in the detailed planning or the planning phase, then we're probably already behind the curve. Really, from my perspective, we should be well up to speed on this in the identify phase. Let's not forget that in identify, our end result here is a plan, a solution to a problem, which is going to get us from A to B. So we'll know what the trajectory is going to look like. We'll know what our hole sizes are. So we'll have a fair idea that we might have to back ream out of a 17½ inch hole, for example. So at that stage, then we should be thinking about, okay, what are the things that we need to do in the planning phase in order to make sure that when we come to execute, we can execute successfully. So this is a holiday snap taken by my back-to-back on a rig back in the middle of 2018. So as you can imagine, I heard all about this one when I got back to the rig, and it was all shovels, all hands on deck in the shaker room, try and get this stuff back in the trough and going somewhere else other than over the top of the shakers. Okay, so again, in common, wellbore stability as a contributing factor, causal event in 17% of the lost in hole events that we classified. So the 2 big things here are mud weight and dynamic pressures. So thinking about the mud weight, biggest contributor. The mud weight that we run is always a balance between having enough density to satisfy the requirements from a geomechanics perspective. So it's mud weight to control breakout, to control hole instability, rather than mud weight for well control, for example. So there's always a trade-off there, and oftentimes with operators, it's a question of, do I run mud weight that's high enough to keep the hole open, whilst I may have some other issue with losses for a similar mud weight or the same mud weight at some other part in the same hole section. So there's always a balance here, and we're oftentimes trying to work out what's the worst of two evils. Is it trying to manage a wellbore stability issue or dealing with losses? And if we get on the wrong side of that, then you can see here, as in the picture, that things can go pear-shaped on us quite quickly. From a dynamic pressure perspective, we're talking swab and surge here. My personal perspective is that this is an often overlooked contributing factor. So oftentimes there's no modelling done to try and understand the impact of swab and surge. Now, for land rigs, or jackups with a non-motion compensated system, no big deal. Then we're just talking about tripping and these kind of things. But if we're on a floater and we have the compensator locked and the drill strings moving up and down, then we're having that constant cyclical loading going on in the wellbore, and over time we can see we can definitely come across or find instances of lost in hole events where that's been a serious problem. So going back to our planning process, where do we believe that, or where do we think we should identify that these are going to be issues? Well, again, very much similar to the problem at number one, the operational issues. From my perspective, it's going back to the identify phase. So we're going to have a geomechanical model, a mechanical earth model, as part of that identify phase to solve the well design challenge in the first place. So we'll see very early on in the process, there's going to be some issues that we're going to have to figure out how we're going to manage or live with as best we can. And the same going from the dynamic pressures, the swab and surge. There's solutions out there in the market now where we can select our rig and we can figure out what the magnitude of these dynamic pressure loads are going to look like over the course of a well. So looking at that, understanding that, getting that understanding early is going to pay dividends later on down the track. So our third or second equal problem event is related to our operational limits. So you might expect that operational limits would be clearly known and understood ahead of time. However, we often see that that's not the case. Now, that might be something as simple as the drillers not believing the mechanical earth model, for example. So, it's not uncommon for us to see a planned mud weight which is lower than the collapse gradient because people simply don't trust the geomechanical model, for example. Or even when we're talking about equipment operating limits, there might be confusion in terms of the value of safety factors or safety factors applied on top of safety factors. So there are lots of uncertainties out there that we often see making their way out into the field when we're least well equipped to do anything about them. So from our perspective here, in terms of our overall management system, where would we expect us to be able to foresee a risk and then do something about it? So in common with everything else, if we're waiting till we're actually executing before we have a robust stuck pipe plan and a combined loading chart which details how much I can pull and twist at the same time, then we're already behind the curve. If we're thinking about identification, then we might have the wellbore trajectory lined up. We might know what the drilling rig looks like, but there's a reasonable chance that we won't have final specification on a drilling string, for example. So maybe in this case, in this example here, then it's not really until the planning phase where we really know in detail what the drill string is going to look like, which is going to allow us to plan our operational limits around the exact configuration of equipment that we have in the hole. This is our last slide on the problem events. So the last four were, just to refresh your memory: differential sticking, hole cleaning, equipment failure, and hole geometry and patterning. So the first two, differential sticking and hole cleaning, have we done our job properly at the beginning in the identify phase, then we should be able to put plans in place to mitigate those particular risks. Although for differential sticking, once we understand what's going on, there are very specific requirements from an execution perspective that we need to have. Whether that's limiting stationary time, precautionary reaming on connections and so on to lay down fresh filter cake. So diff sticking, you could argue, is a combination of identify and execution. Equipment failure, from my perspective, is very much a planning thing. So when we know what we're going to be doing and what equipment we're running and where it's coming from, then we have a whole suite of activities to undertake from a quality control and a quality assurance perspective, in order to make sure that we assure ourselves that what we're getting is going to last and do what it's supposed to do when it goes down the hole. And then the last part here, from my perspective, hole geometry and patterning. So that's an execution thing. I'm not aware of any fancy software out there that's going to tell us exactly when we're going to be susceptible to a hole geometry issue. So we're going to need to be monitoring our LWD measurements, our survey measurements, our vibration and so on, whilst we're actually undertaking the drilling process in the execution phase, in order to try and understand if this is occurring, and then avoid it or to make sure that it doesn't bite us later on. So a few slides earlier, I described the meta-analysis and the assessment that we made that these events were avoidable. So avoidable equals foreseeable. So if they're foreseeable, what's causing it? Was it a personal competence issue? Well, in 22 years in the industry, it's very rare to come across individuals that you might deem incompetent to do the job that they've been asked to do. So if it's not a personal competence issue, what is it? So how does our company and the way that it operates affect the final outcome? And isn't this what our management system is supposed to control? If the system controls the workflow, why are we missing things? And we'll talk about that on our next slide. Right, so what have we talked about? Well, we've had a little bit of discussion on the management system itself, what it is and how it works. We've talked about some of the key issues that we see from a well construction perspective, what causes them, and where we should be looking in our management system to plug the gaps, if you like. But just to extend that a little bit further, the last slide in the presentation here is just a little bit more of a development of some of the things that we've kind of talked about during this presentation so far. So in order to avoid you having to read any more words, I've got 5 little infographics here. So proceeding from left to right, I have a schedule, which is indicative of time. I've got the management system itself. I've got KPIs here in the center. The little dumbbell here represents strength and depth. And then finally, we've got the cost versus value seesaw. And as you can see, it's landing correctly at the moment with value taking precedence in this little graphic. But we'll talk about each of these in a little bit more detail. So timing for me is a big issue. If you are pressed for time or stressed, or there's some external stressor in the system that's not allowing the operations team to work through the plans or the phases with enough detail, then there are going to be problems. As a senior drilling engineer or drilling engineer, it used to take me a couple of days in order to figure out what I needed to do if I was presented with a drilling problem. I've been told I'm a little bit slower than average before, so perhaps that was just me. But my feeling is that people need time to reflect on issues, on problems, and to be able to integrate a proper understanding of that into a firm solution. So I'm a big believer that successful teams have the resources and the time in order to be able to plan effectively, and we see that on some of the better ERD developments that that we have information on it that we've been part of. So that's the schedule or the timing. Part number 2 is the management system itself. So that's designed to create a consistent output and to provide assurance for the operator, the person managing the system, and the people within that system that the work that's being done and they're creating is up to a certain minimum standard. So these systems and technical procedures and so on is the drilling engineer's friend. So if you can stick to what's the guidelines contained in your system and you work to that, then big tick, gold star, and so on and so forth. There's very little that can go wrong if you're following the requirements and you're getting your stage gates done in enough detail. You have third-party challenges and so on. So the system itself is a good way for us to protect the sort of performance or level of assurance that we're looking to deliver. The central point, or the third one here, is around the management of KPIs, or the choice of KPIs that we're going to use to benchmark ourselves in the drilling process. So as an example here, perhaps if you've got a 9 5/8 liner to float over 30,000 feet, then chasing on bottom ROP in the first or second well in the sequence isn't the KPI to choose if that 9 5/8 liner run is critical. So choosing the correct KPIs, it's a bit of a big boy or big girl discussion depending on the company that you work for, but it's critical to drive the right sort of behaviours within the engineering planning and the operational execution. So as a question, do most management systems have a section in there about definition of the correct KPIs for a specific job? In my experience, no. So perhaps that's something as an industry, or you can take back to your employers and figure out, am I using the correct KPI for the job at hand here? The fourth point is about strength and depth. It's about having redundancy and capability and competence within the team that are going to implement, identify, plan, execute, measure, and review as that last piece of your management system. So do you have enough capability that if someone gets sick, falls under a bus, then you can move on and guarantee the same results as you would if you're fully staffed? If yes, great. If not, then maybe that's a conversation to be having about cost versus value, which handily takes us on to our last piece here. So that here is the perfect example. Are you focused on minimizing the cost of individual line items, or do you have some flexibility within your way of doing things within the system to prioritize tools or techniques or resources which may not necessarily from an individual line item perspective be the lowest cost, but in overall well construction terms provide you with the best value outcome? And then going back to the question about strength and depth, or KPIs, how is that integrated into your management system? Is there a paragraph on cost versus value and some guidance as to how to handle a situation like that as a jobbing drilling engineer? So, lots of things to think about. No magic bullet fixes for issues, with management systems and failing project teams and so on, but just a number of lessons to be learned from successful projects throughout the industry, focused on the 5 factors in front of you just now. Well, thank you very much for your attention. So I'll open it to the floor. If anyone's got any questions, please let me know. Thank you.